Hey everyone, welcome to the Fairblock Cosmos Integration Quickstart. My name is Hash Titan. Y'all can call me Hash, a DevRel contributing to the ecosystem. And today's tutorial is going to be covering general Cosmos chain integration at a high level. And it'll showcase this via a unique version of the typical governance module found in these chains called privgov. We think it's pretty neat and a fun showcase for Cosmos integration. So with that, let's get started. Today's tutorial will hopefully be around 30 minutes or so, depending on my time management here. And it'll first jump into a primer on Fairblock and specifically how it works with Cosmos chains. From there, we'll get into some context on the privgov module itself. And then we'll walk through the actual code, so the actual tutorial, covering details on the privgov code and running the script showcasing its functionality by submitting an actual encrypted vote. And lastly, we'll then cover next steps for folks to take, and we'll wrap things up from there. So in general, you can find other videos sharing Fairblock's overall vision. More content is being created as we speak. But for convenience sake, I'll touch on a few things for you, Anon. I know times are a little crazy nowadays in the world, so we'll take whatever we can get, right? So with that, Fairblock leverages dynamic confidential computing, and essentially with that enables a whole suite of new applications leveraging such functionality. So basically, like we call these in quotation mark credible applications that are being unlocked. And what that is referring to is essentially apps that operate in a way that allows for confidentiality in a reasonable manner. Like imagine having confidentiality and confidentiality computation, like that aspect available in the blockchain. You're basically unlocking a bunch of different ways of creating apps and thus increasing their credibility and thus being called credible applications. And with that, it should be noted that with Fairblock, it can actually host its own applications within its own ecosystem, Fairy Ring, and provide that dynamic confidential computing within its own like ecosystem. But on the other side, it can actually partner with other networks and other chains and other applications as a whole and provide these functionalities to it for dynamic confidential computation. So some app examples like we couldn't have, it's worth noting, like without having something like this for confidential computation, that includes things as simple as like voting, right? Like proper voting, or sealed bid auctions, or even DeFi with MEV protection. And the sandbox is quite large. It doesn't just go stay in like the DeFi world or the incumbent world of like DeFi within blockchain or other applications that we see in blockchain, like meme coins or only like that. But it can actually extend to like say gaming or even like the newer like just newer applications that are coming for the forefront today within the crypto ecosystem. So, but today we're going to be focused on a quick example of encrypted voting. Before we get into the encrypted voting, though, it's really worthwhile to go over the architecture with Cosmos integrations in general. So, firstly, we'll start with actually the general integration side of things in terms of architecture. And with this, like really, there's just a couple main components to touch on. There's going to be a separate architecture video that goes into greater detail if you'd like to check it out. We'll share the link appropriately. But essentially, the main things that I wanted to touch on when we look at the high level architecture is that there are, in my mind, actually four main high level components. And then when it comes to the UX, there's like two main, what I call them blobs, really, in terms of like steps in the UX. So let's cover the high level like actual components first. So what I'm referring to is the first one being like the example chain or the destination chain is what it is referred to in the documentation often. And this is just the partnering chain. All this can actually be existing within Fairy Ring itself as an ecosystem. But since we're talking about it in the context of Cosmos, let's just talk about it as if this destination chain is a Cosmos chain. And From there, the second component is the actual fairy ring network. So in the case of partnering with a Cosmos chain, it would be working with different threshold MPC schemes, aka like different confidential computation methodologies. And today we're covering the usage of threshold IBE or TIBE. And basically what happens is master public keys as well as decryption keys are sent to the respective destination chain to be used in accordance to, the typical UX, which we'll cover in a sec. And then there's the third high-level component, which I like to talk about, and you don't really see it in this schematic, but it's the Fairy port. And basically it's a software that takes care of like the communication between the destination chain as well as Fairy ring. So sending and receiving the respective like master public keys and the decryption keys accordingly, for example. And then lastly, there's what we refer to as FairyKit. So it's not on this schematic itself, but in terms of like labeling. But the Fairblock encryption SDK in our mind is basically a subset of the FairyKit. And so FairyKits are just a general term to refer to bespoke software that allows the integration of different ecosystems and different networks. So whether it be an EVM chain or a Cosmos chain, a respective bespoke FairyKit would be used accordingly. And so in today's example, when we talk about general high-level Cosmos integration, we would be referring to using the Cosmos FairyKit. Okay, and now it's really worthwhile to touch on the overall UX. So when it comes to the high-level UX, we'll just walk through the schematic and make some sense of it. And so basically, the user comes along, and so this is like a general application, whether it be Cosmos, EVM, whatever, right? The destination chain can be whatever respective network type. So the user will come through, and they'll submit an encrypted transaction with the designated decryption conditions. These conditions are basically what will be used to trigger an event emission later on, such that the decryption keys are sent from the Fairy ring network to the destination chain to decrypt things accordingly. Okay, so essentially, in terms of blobs, we're just going over the first one, right? So basically, the user submits the encrypted transaction with them outlining or however like their decryption conditions regarding that, and then from there, the application front end will work with the respective like FairyKit. So in this case, the subset, which is the Fairblock encryption SDK, to submit the encryption transaction, it'll be encrypted using the respective public key corresponding to this respective condition. And then thus like later on, the decryption key respective to that condition will be used to decrypt. But let's keep going on with blob one. So user submits encrypted transaction with the conditions. Transaction gets actually encrypted using the SDK and using the public key corresponding to said condition. And then finally, the encrypted transaction is stored in the mempool, awaiting for it to actually be used and executed within the destination chain itself, in this case. So that's the first blob. The second blob, or second step, let's call it in the UX, is essentially the condition is hit. Let's say it's block height. And then from there, an event is emitted from the destination chain and is actively listened to, like the destination chain is actively listened to from the relayers, Fairy port, whatever, in terms of like relayer software. And from there, the actual event is picked up and it's seen like, okay, decrypted conditions are met, and essentially is communicated with Fairy ring. And this is where like the threshold aspect comes in. Essentially, the validators within Fairy ring will then construct the respective like thing necessary for the MPC scheme in question. So in this case, we're using TIBE, so threshold IBE. And so the decryption key is going to be created respective to the condition and like the transaction that's being referred to in the event emitted from the destination chain. And then as a certain like threshold of aka like portion of that decryption key is created, the rest will be extrapolated. And from there, it'll actually be sent along with Fairyport or whatever relayer to the actual destination chain to be used by said application logic or chain logic to then decrypt and then thus execute the transaction that was stored in the mempool. And then you have the transaction is decrypted and is executed. So in a nutshell, right, you basically have submit transaction with decryption conditions. Then that transaction is encrypted using the public key respective to those condition IDs. And then finally, it's stored in the mempool, and then it's the events emitted such that the condition is met. The decryption keys are generated from the fairy ring. That decryption key is sent along, and then boom, you have the decryption key within the destination chain and the app logic, and it is then used to decrypt the transaction and execute it accordingly. So we'll keep going here. Another thing to note, now that we know like the overall high level architecture, and you might be asking like, man, why are we governing so much high level architecture? Like, would you, I don't know if you play Zelda, but it's like, would you go into a dungeon without a dungeon map? Like, yeah, but you might have a bad time. So we're just trying to highlight, certain things to help everyone digest everything before we get into the actual nitty-gritty code. And so when it comes to the actual like Cosmos integration, now that we have an understanding of the high level architecture, basically all the same UX applies as described in the general high level architecture for chains working with Fairblock. But the only difference is that the decryption and execution layer methods are a choice up to Cosmos chain developers themselves. And what we mean by that is that like if we think about if you think about applications that are being hosted within, say, Fairy Ring, the network itself, we refer to that as like you're dining in, you're like hanging out in the Fairblock ecosystem. Whereas if you're a chain that wants to partner with Fairblock, then you're using the delivery method. And that essentially is what's seen in this schematic here. Chains integrating with Fairblock can often choose between, say, like using the FairyKit method, as mentioned before. It's kind of like this agnostic, bespoke kind of software, depending on what respective like network you're using. So in this case, Cosmos chains, or it's the co-processing route, which is seen here, and we'll cover like the details of each of them right away. So like with Cosmos chains, the FairyKit route involves Fairy Ring handling the cryptographic computations and the encrypted transactions processing, including decryption and execution happening in the Cosmos chain itself. Okay. And whereas the co-processing route, it involves the transaction happening in Fairy Ring and only end state / results are being sent back to the integrated Cosmos chain. Okay. So like everything is happening in Fairy Ring and then everything is the result is being relayed back to the Cosmos chain. Depending on the design scenario, one method will prove to be better than the other. It's really just kind of like a design decision. In our case, we're going to be using like the privgov module to exemplify like the FairyKit method. Privgov was chosen as an example because of like its general application, in the sense of like its governance, it's understandable by general crypto. And it's used within the Fairy Ring itself. And then finally, like some other things to note from the schematic is that communication, like it's specific to Cosmos integration, is that communication between the D chain or like the destination chain and Fairy Ring. And basically with it, it happens using Fairyport, IBC, and relayers. So for example, like the master public key or MPK is always sent via IBC. And the other thing to note is that there's two types of decryption keys. So there's per block decryption keys and general decryption keys. And in our case, with the example we're using, essentially, privgov uses IBC since it's dealing with general decryption keys and conditions other than block height, the proposed like time frame. It should be noted though that like Fairyport essentially is used for speed, whereas IBC can be used for more like secure and reliable transmissions that aren't so based on speed. Ew. Okay, we got one more slide, this one here, before we can actually jump into the quick start and on. Pause whenever you want, like totally understandable. If you want to go touch the grass, get outside, order some Domino's, but otherwise, let's get into it. So just to kind of like recap what was just covered in terms of like overall Cosmos project architecture. we have kind of like the general term like FairyKit. And in this specific setup or like Cosmos setups typically, you can use something more so like, with modules. So it's kind of like modular FairyKit or FairyKit modules. Um, and as well, you can just use the execution logic. So smart contracts, or you could do something kind of like a hybrid setup similar to what we'll show you today with privgov. And of course, you can do co-processing as mentioned briefly in the high level overview, where essentially the computation and execution is carried out within the actual fairy ring network. And then the result is sent back to the respective Cosmos project. And so a little bit of fun details about privgov. Essentially, if you're going to be integrating into your own SDK chain, like today's tutorial will be walking through an example SDK chain, yeah, there you go. And using and essentially from there, it's showcasing like, hey, all you have to do is modify the go.mod file and establish IBC router connections for the respective gov module. And another cool thing is that it's actually just a simple fork of the Cosmos SDK chain. So essentially, sorry, SDK gov module. And with that, right, it just shows that it's like much more easier to integrate into a respective Cosmos SDK chain that's pre-existing. And what it really does, right, in a nutshell, is it offers the ability to create governance proposals where encrypted voting can be submitted, and decryption is done once the voting period is over. And you'll be able to see kind of like the end result, where essentially event emissions for said completed voting proposals are picked up by the relayers, such that decryption keys are sent to the D chain or the destination chain for decrypting the end result. All right, now we can finally start walking through some code. Let's go. Okay, so here's the repo, privgov. It basically is a blockchain built using Cosmos SDK and Tendermint and a mixture of the PEP module created with Ignite CLI. So it's essentially a basic working Cosmos chain um, that uses the Fairblock Cosmos SDK to enable private governance instead of like the typical Cosmos SDK. And before getting even more into it, like as mentioned, governance is a good example to walk through for using encrypted transactions. If you think about, the last 4 years, without what we've seen, it's been entertaining on crypto Twitter, but it's also been not a great time where we've seen, just voting processes be influenced by collusion, monetary and social pressures, and just overall other bad effects that are influencing the democratic voting system that was meant to be within the blockchain system's hopes, right? So here, like since this repo is a Cosmos SDK chain, it is really straightforward to integrate privgov into your own SDK chain as well. So we'll show that right away. Basically, what we have to do is you just go into your SDK chain and modify the go.mod file with the replace clause as you see here. Now, after we post this video, the README will be updated to actually include more individual notes per each of these changes. But really the main detail, as mentioned before, is using the Fairblock Cosmos SDK fork, where further modifications were made to it because compared to the default SDK module, the default doesn't have IBC capabilities, no support for encrypted votes, processing them, etc. And so this fork is modified and maintained by the Fairblock org. So definitely feel free to check that out. It's got a lot of guts to it. But with that, right, once you've made this modification to your SDK chain, and in the go.mod file, then all that really is left to do is make sure that the custom gov module is registered with the IBC router. And all we have to do there is just modify the ibc.go file with the code outlined here. And basically that's it. We actually can start now running the actual tutorial. And the first thing we're going to do when running the tutorial is running the actual setup script. And what that'll do is it'll set up and start the fairy ring chain with all its bells and whistles. It'll set up and start the privgov chain. And lastly, it'll create an IBC channel between the fairy ring chain and privgov chain and start the Hermes relayer. And a quick note is that if you're running a Mac OS system, there's some extra steps that you may have to do to get everything running on your machine. So like obviously making sure you install the appropriate dependencies required, using Homebrew or what have you. And also note that with Mac OS, its default version for Bash may not be consistent or congruent with what actually is needed for this tutorial. And so you'll have to kind of investigate on your own setup. For example, for myself, I just specify the respective like bash version that I need to use prior to running the actual script file. And you may need to do that as well for the Go versioning, depending on how you have your system set up. Cool. So now we could actually talk about setting up an actual proposal using a setup repo. So I've cloned this onto my local machine, and for the sake of time, have already ran the setup. Setup takes about 5 to 10 minutes, depending on your internet, depending on your machine specs, etc. So I've already set that up for the sake of time. But basically, what we're going to do is use the commands outlined here that have been made for this tutorial we'll go over them high level quickly first before actually walking through them and running them. Is first, we're going to submit a proposal from user Fred. And this is all like local testing, right? So onto your machine. So we'll submit a proposal, and I've made it so that proposals are 5 minutes. When you do the setup script from before, you'll be prompted with how long proposals should be. So we recommend doing it with like 4 minutes or 5 minutes because obviously real proposals are going to be several days or even like longer timeframes or whatever. But for iterative purposes and testing, just set it up as 4 minutes or 5 minutes, and that way you have enough time to like manually type in a encrypted vote and submit it, and then can actually see the results of said vote, like we'll see today. So this is the command to actually create a draft proposal. We use it using a draft proposal in a JSON format. And then as for the querying of the said proposals, you'll need to query it to get information such as like the resultant publication key, or sorry, resultant public key for encryption, and then use that actually to then create the ciphertext. So that's actually what's happening in this generic command. So the first command, in terms of actionable command, is creating the proposal. The next one after that, besides querying the proposal itself, is then getting the pub key. Sorry, is encrypting the vote using the pub key as well as the identity associated to that proposal. And then finally, after that, you actually have a resultant encrypted vote as a ciphertext. That's what gets returned after you run this command. And so what you'll need to do is actually submit the actual vote. So you'll vote encrypted or submit encrypted vote, right? That's pretty much what you're doing. And you'll need the proposal ID and the actual encrypted data. So like basically the return value of when you run this second command, encrypt vote. And finally, after you do all that, then you can query the proposal again and then see the end result that basically the proposal has actually received encrypted votes. And then we just wait the time frame and see if the proposal succeeded. Okay, so let's do that actually in practice. So here we have the setup done in terms of the binaries for this repo. So here you can see we're submitting the details for a new proposal. So I'll go ahead and say yes, confirm transaction before signing and broadcasting. Great. Now we need to actually query it to see if the details are there, like the pub key and everything else we need. So here you can see, yeah, summaries, blah, blah. These are just like generic, generic example proposals. But you can see here the pub key is not shown. You usually have to wait like 10 seconds or so. A little bit longer. Here you go. So now you see the pub key and other details here, and then we'll have the identity as well as ID. Those are two separate things. Make sure you note that. And now we can move on to actually encrypt the vote. So what we'll need here is the identity, a random salt, and a pub key. The appropriate pub key, right? So like that. So the ID is 1 over RQ, and the salt, we do 1, 2, 3, 4. And the pub key will copy and paste that in as well. Great. And now we have this result in ciphertext. Okay. So what we're going to want to do is put that ciphertext into here. So I'm just going to use the markdown for my benefit to make this easier. And so let's just say we do this. And then the proposal ID, as we saw before, it's not the 1 over RQ, it's just 1. We'll do that. We have to make sure like spacing and all that is consistent. Sometimes when you're working with like Mac versus Linux, you can have oddities occur in the spaces by default. So just be wary of that if you start having any issues. But here we go. So we'll submit that. Okay, it's saying confirm the transaction before signing and broadcasting. Good to me. And now we can just query again the actual, I'm going to remove this so it's still just generic. But now we can query the votes one more time and see it's still in the voting period, but now we have encrypted votes. Like has encrypted votes is now a bool of true. So now we'll just wait. I'll just skip ahead. It's just we're just waiting the duration of the 5 minutes for the rest of the proposal to see the end result. Okay, so I've skipped ahead and now I've actually queried the proposals again. And here you can actually see, boom, it passes. So that's great. Essentially, what we've done, let's recap for a second, is we've now actually finished running a proposal using the privgov setup shown in this tutorial. And we successfully submitted encrypted votes into it, which is awesome, using Fairy Ring and Fairblock. So, and to recap even further, like with this whole tutorial, the overall, like the big gotchas, right, are that, of course, going over what Fairblock is, its overall high-level architecture, but more so for Cosmos integration, that there's a mixture, there's a lot of different ways to use the Cosmos FairyKit. So basically, in my head, the way I look at it is that the Cosmos FairyKit, there's a lot of like different unique integration subsets or tools within the FairyKit for Cosmos. And in this case, we have a pretty unique one, but still there's like aspects that could be gleaned for any other general Cosmos SDK chain integration, such that in today's tutorial, we've gone over more so using like the module tools a little bit, such that we use the PEP module and like use aspects from it, and then combine that with the unique like execution logic that's seen in this SDK chain example. And so with that, we implore other developers watching this video to actually go ahead and experiment with their own Cosmos SDK chains. Feel free to reach out to us as always, and we'd be stoked to actually like see what we can innovate on together using this confidential computation technology and functionality provided with Fairblock. And so with that, basically the code section part is done for this tutorial. Let's move on to the rest of the slides. Sweet. So with all that, we can see the power of Fairblock in action in an example within the Cosmos chain ecosystems. So what's next? Well, you see, now with Fairblock, safer apps can be built. There's always so much risk in crypto, so why risk it without Fairblock? So in general, here are some next steps to take depending on which route you want to go. For folks integrating, check out the docs and the Discord, and feel free to reach out to the core contributors from there, and we can start the dialogue respective to your project. And for those who want to dig into things more, like you know how to look at tutorials, but today was kind of like a quick start run through. If you look at the README, there's like a more detailed outline of things if you wanted to just like jump into things more within the README itself. So I would highly recommend kind of like playing around and actually putting in the privgov code into your own SDK chain, for example. And if you're a community contributor, we're going to be opening up a repo for general integration issues or to help improve the processes. So we'll share the link in the Discord soon. And with that, I'd like to thank you so much for watching. Hopefully you have now seen the power of Fairblock in action and are excited to build with it. Feel free to reach out to me on Twitter or Discord at #Titan. And yeah, I'll see you later. Get the heck outside.